Hey guys, this is Mr. Nis. Today we'll be going through your Chapter 6 Part 1 video notes over motion, reference points, and distance versus time. We'll start off first with motion. Motion is measured as a change in distance over time. If an object moves a given distance over a period of time, then that object is considered to be in motion. For example, when you are walking to school, you are moving your body towards the school, and you are considered to be in motion. A reference point is an area or an object that is used to compare changes in position. In order to use something as a reference point, its position must be fixed or non-changing for an extended period of time. Objects that are only stationary short-term should not be used. For example, a car that's parked on the side of the road, it could begin moving at any moment, so you shouldn't use it as a reference point. Because of this, common objects that can be used as good reference points include buildings and trees. If an object's position changes relative to a reference point, then that object is considered to be in motion. Now we'll look at how to graph motion. So we know that when constructing graphs that display data, that the independent variable always goes along the x-axis and the dependent variable goes along the y-axis. Since time is an independent variable, it is graphed along the x-axis. And since distance is a dependent variable, it is graphed along the y-axis. The starting position of an object is located at a distance of 0 units on a distance time graph. Whether it's miles, meters, feet, whatever unit of distance is being used, that's the starting position at 0. Now, the object might not always start at a distance of 0, as we can clearly see in this example. This graph might be the motion of a person running compared to a tree, where they first start running when they are 3 meters from the tree. Okay, they might not start running at the tree. They eventually turn around and run back to the tree. As you can see over to the right side of the graph, the distance drops back down to 0 meters. So it started at 3 meters, dropped down to 0, the person ran back to the tree, even though he didn't start at the tree. Okay? Nevertheless, the majority of the time, an object's starting position is at a distance of 0. Horizontal lines on a distance time graph indicate that an object is stationary, which is just a fancy way of saying that something isn't moving. Okay, the object is at rest. While time continues to increase, the distance traveled neither increases or decreases. The object isn't moving anywhere. Okay, it's staying still. A straight line that is moving upwards indicates increasing distance from a starting position at a constant speed. Okay? A straight line that is moving downwards indicates decreasing distance from the starting position at a constant speed. The speed of these objects is constant since the amount of time it takes to cover a given distance doesn't change, whether they're going from 0 meters to 1 meter or 2 meters to 3 meters. In these examples, the amount of time that it takes to cover that 1 meter distance is always the same. However, the steepness of a line on a distance time graph indicates speed. The steeper the line is, the faster the object is moving. In this example to the right, the object represented by the dotted line is moving much faster than the object represented by the non-dotted line, due to it being steeper. This part may be kind of confusing, but try to stick with me. Part A of the graph to the right indicates acceleration away from the starting point. The object is speeding up while moving farther in distance from the starting point, while Part C indicates acceleration towards the starting point. Now the object is speeding up while moving back towards the starting point to a distance of 0. Okay? Part B indicates deceleration, slowing down away from the starting point. Okay, so it's slowing down while moving farther away from your distance of 0. While part D indicates deceleration towards the starting point. Okay, the object is slowing down while moving back towards a distance of 0. Okay, I understand this might be kind of confusing. It's hard to explain it through video without me being able to show you in class. So if you need further help, please ask in class. This picture is a great example of many different types of motion. Okay, take a minute, pause the video, and take a few moments to study the different types of motion in this example. This next graph shows the motion of a bus as it is driving. The bus starts at the bus station and then begins to travel over line segment OA. This line segment shows that the bus travels 10 miles at a constant speed over 4.5 minutes. The bus then stops and remains at rest, doesn't move anywhere, for 5.5 minutes, shown by line segment AB. Line segment BC shows the bus travels 10 miles back to the starting position, back to the bus station, and this takes about 2.5 minutes. Okay, this is an extremely fast bus to travel all those miles in such a short amount of time, but the graph is what's important. Okay, what is the bus's motion like over the line segment DE? What about line segment EF? Take a few moments to think about it, refer back to the graphs shown previously, and try to figure it out for yourself. Okay, the very last section of your notes is a graph that shows the motion of 3 different runners during a race. Use your notes and the information in this video to try and answer the questions listed. Which runner placed first? Which placed second? Which placed third? And which runner just stopped running in the middle of the race? Okay, take some time and try to figure them out. I hope you learned something while watching this video. If you are ever confused about anything in this chapter, make sure you refer back to this video or your video notes for clarification. You can also use your textbook. And as always, you can ask myself or Mr. Miller for help in class. Thanks for watching.